Hello, and welcome to the Data Engineering Podcast, the show about modern data management. It's 2024. Why are we still doing data migrations by hand? Teams spend months, sometimes years, manually converting queries and validating data, burning resources and crushing morale. Datafold's AI-powered migration agent brings migrations into the modern era. Their unique combination of AI code translation and automated data validation has helped companies complete migrations up to 10 times faster than manual approaches. And they're so confident in their solution, they'll actually guarantee your timeline in writing. Ready to turn your year-long migration into weeks? Visit dataengineeringpodcast.com/Datafold today to learn how Datafold can automate your migration and ensure source-to-target parity. Your host is Tobias Macy, and today I'm interviewing Sam Kleinman about database trade-offs across operating environments and axes of scale. So, Sam, can you start by introducing yourself?
Yeah, sure. I am a software engineer with a eclectic background, I guess. I live in Brooklyn, and I worked I spent a long time working on MongoDB in a couple of different roles, and then have spent some time working on other engines, Neon, and also a startup called ClarityB. And I think databases or database engines are sort of the, I don't know, have always sort of been the biggest lever in sort of that you can jump on to impact the way that software engineers are able to be productive and build cool things. And so it's always been a really exciting. It's weird to say, oh, databases are exciting, but they have always been an exciting place to do work and see and have an impact on our industry. So that's sort of how I got here, belatedly.
And do you remember how you first got started working in data?
Oh yeah, no, I have a liberal arts undergraduate degree in social sciences, basically, and interdisciplinary stuff and I had a dumb job in college, filing paper for the fundraising department in file cabinets, which I can't imagine anyone ever used, but it was a sort of Keynesian economic endeavor. And I would listen to podcasts, which is a thing. It's ironic, here we are on a podcast, but I don't listen to a lot of podcasts since then, but I listened to something where they interviewed some people who were working on, this was sort of in the last data tooling uh, boom, and I listened to people talk about a lot of these databases that were it was the sort of peak of NoSQL's sort of, or the heading towards the peak of NoSQL's moment, and I was like, oh, this data thing is real big and gonna, it sort of seems, and I had been interested in open source, and I had always been a nerd, but somehow as a young person, I was very resistant in taking CS classes or whatever, and so I never really studied it, but I definitely got interested in learning about the technology, and thought that there's a lot of cool things to be done around infrastructure. And so I think I kind of, it's sort of weird now. If you say infrastructure, it means you're a sysadmin, and I'm not exactly a sysadmin. But I think infrastructure in this abstract sense is really cool because of what it enables, and the sort of power, the ways that infrastructure lets you focus on the important things of your problem. And databases mean that you're not spending lots and lots of time sort of figuring out how to absolutely indelibly save data, or make sure that you recall, there are these problems that databases just solve for you. So as a programmer, you don't have to sort of wonder if you've written the search algorithm correctly, right? You just select whatever you want. And I think that that there's like many levels of that. And I think we're actually like, I mean, we've been having relational databases for however, 40 years. And we are like not yet to the point where the abstraction between application code and state persistence and retrieval code or the database engine, like that boundary is not exactly where it should be. And it's like interesting to watch it sort of settle over time, like over the like long time. But yeah, so all of those things like have sort of, and then you get a job and you keep working at it. And then your next job looks like your previous job, and suddenly suddenly you have a thing, somehow. I think that's an accident that many of us kind of stumble into.
And on the point of database engines, they are the system of record for whatever application or service or system you're building, where database is a very broad term where it can be anything from I happen to have written a file to disk and then I am reading it back to some of these deconstructed database engines where you have the lakehouse architecture that's emerging, where you have a query engine, you have some object storage, your auth lives somewhere else, and everything in between across different modalities of data types and data formats. Vectors have become increasingly popular as a data type because of the AI growth.
Yeah. Well, and there's indexing is sort of a classic. Like I kind of actually think of like there's a lot of vector search problems which are like subclasses of indexing problems, or sometimes they can be. There's also like database is an abstraction. I think that's the thing for doing this like save, access, and retrieval piece. You said something that I thought was great. This like deconstructed database. I think there's this sort of orthogonally to all of this, what is a database, right? Like there's also these questions about how we build applications and that shape how you need to save data. So you have, there are very architectural decisions which influence the shape of the data that you have. There are deployment considerations which shape how you deploy things. There's like patterns or like workload properties that constrain how you manage the data that you have. I think the truly revolutionary thing that's like happened in the last 15 years in computing, I think, is that like S3 has become reliable in a way that's kind of alarming, cheap in a way that's also alarming, and ubiquitous. And I think that, and the cheapness makes it ubiquitous, but that means that it used to be that databases were like, how do you attach enough disk to a machine that has enough RAM to do the thing that you need it to do? And the like the size of the disk and like that was the sort of thing that mattered. And now like you just put it on S3, you can like network having storage that is connected over Ethernet rather than like over like some sort of PCI bus or whatever SCSI bus is like that shift changes how all of the rest of these systems work. And I think it lets us as database makers, engine makers, separate storage from compute and have them very separately. And that's really powerful. And it gives rise to like some of these like serverless things that are cool. And I think again, we haven't quite seen all of it. Like there's going to be like S3, as good as it is going to get better along a number of dimensions, and I think we'll start to see even cooler things there.
And I think on the S3 point, there have been a few developments over the past 5 or so years that have also increased its utility. Most notably, the read after write consistency that didn't exist for a while, where you would make a write and then, depending on where you were reading from, it may or may not exist yet. Now they've got guaranteed read after write consistency. And most recently, they've added a optional update pattern where you can say only update this file if it is actually different than the one that I'm trying to upload, which can add a lot of efficiencies as well as far as IO for conditional updates or where you're not actually changing any of the data.
Yeah. No, it's, I even think the like non, the like in the inconsistent read after write version of S3 is like so good in a lot of ways that you or that I like. I don't even think about all these other things. Is I'm like, yes, this is great, of course, but I think they've also been adding like faster S3 tiers, which are more expensive, but like give you a level of consistency, and then you can do all these like crazy tiering. But regardless of all of that, it means that you can like allocate your compute very elastically and not have to worry about stateful, like not have to worry about managing disks, right? And it's actually like when people are like, why do you need a new database? Aren't the things that we have good enough? And like the things that like these like old industrial battle tested pieces of software are really good, and like it takes a long time to make a database kind of robust in that way, just because like you have to bang on it from all sides. But they all assume local storage in this way that like you can sort of rip out the bottom and put something new in, but it doesn't, it like the transition from like co-located storage and compute to separated storage and compute is like a really huge change in like in the software, and sort of getting us to that point, I think is really is going to be is an interesting like technological shift that people writing software today are just beginning to sort of figure out how to do. And there are a lot of legacy tools which are sort of sort of shoehorning themselves into being serverless in a way that is like absolutely not gonna like fly from a, I mean, frankly, from an accounting perspective, let alone like technology. But I think it's this is another thing that's super interesting to watch.
And one of the points that you made early on is the impact on the system design that the database has. And I think that that's definitely a very real consideration for anybody who is trying to design or evolve any sort of service, whether it's a consumer facing transactional application or a analytical workload or machine learning system. And I'm wondering if you can give some of the main points of consideration that engineers and teams need to be thinking about as they're starting to determine what is their persistence mechanism for the system that they're building and how that shapes the capabilities of that overall system.
Yeah, the it's sort of I think that I often kind of like think about backing into this in a different way, or like the answer to the way. So I think we'll get there, but it won't feel like it for a little bit. So I think like the thing that you end up wanting to do is to think about the queries that you're running, and think about things like, how does the data get updated? Is this aggregating data from a lot of different places, or is this data that we're writing and reading? Does data get modified after it's created or not? There are some kinds of data where that's true or not. There's also a expense question, like how much money do you have to spend on engine, on the like on the database? And then there's this like, this sort of hints at like the analytics question, but like, are you returning records in some kind of lot like business object record of that is like persisted in a database, persisted in the database and modified in the application? Or are you returning aggregates or computed values that sort of summarize larger parts of the data set. And the thing, or sort of, so like once you answer those questions, once you have answers to like what kinds of queries you're doing, which really kinds of depends on like, there's no wrong answer to any of these questions. There's just, you sort of like, you have to do the thing where you write all of your business objects on index cards and lay them out in front of you and see how they interact with each other, and where the, you know, what needs to, where things need to go. But you, that's a very old school way of thinking about this, I guess. But you once you sort of have that, like what are the components, what are the objects in the system, and how do they interact, you can sort of, and then you have to figure out how you need to save them, and or where the objects exist in existing systems if they're like accessed over APIs. And then so you have to like, once you have where all of the data is and have all of the the like components and the objects, you start to sort of think about how you're going to use it in whatever thing that you're building. And there are lots of different tools which do, you know, will do sort of like one thing really well, and a few things less, like fine but not great. And the challenge is like always like picking the sort of the best tool for what you're doing and what you're planning to do based on how and where you're going. And I think the like the thing that I the thing the sort of key things are like, write throughput is sort of hard to, like, that's like, there are some, I guess, like maybe actually the way to think about this is like, what do you need to think about first, or like what are the things which you can't compromise on. And so there is this like write throughput is really like, if you pick a system that has slow writes, it's really hard to make it fast. If you have a system which doesn't really support efficient updates, then you can't like, and your workload is very update heavy, then you really like, you're in trouble. And then you sort of like go, there are like, you know, so like in some ways like insert throughput, update throughput, and then various kinds of like, can you do recall at the level that you need? You can make, there are ways of making every query fast. If you're determined, you can make a database give you a query faster usually. But it's hard to make it write faster if you're sort of like teetering on the edge of its like tolerances. But I think one of the sort of big one of these like big sort of top level sort of properties of engines is like, is the data stored in a like row oriented format or a column oriented format? And I heard, and I, you know, as a early career pre working on database engines, like heard these people say columnar databases, and it took me a like really long time to sort of make sense of like how and why this was important. But basically the idea is that if you, so row oriented is very sort of reasonable, and you can think about it. You have records or rows. Everyone sort of thinks about this now as like an Excel spreadsheet, but you know what a row is, and all of the columns, all of the fields, positions in the row are things that you like are related to each other. And then columns, right, are sort of all of the different values for each of your records are stored sequentially. And so you have like every, you know, if you have an ID and a you know, like a name and a balance and a last updated time, you would store the names and then all of the balances and all of the last updated times. And when you do that, there are like ways to compress it more quickly, and there are ways of computing averages very quickly, because you can just sort of like shove shove the data through the processor. Really, there's like very little copying that goes on. It's straightforward and quite fast. And this is how analytics engines like make things fast. Is they just write the data out in a way that makes the query that they're going to do quicker. And so knowing how these things work is like really lets you answer the questions of like what kind of engine do we need, because we're going to be computing averages and so we need a columnar format, or we're computing rows and so we need, or we're like recalling one row at a time or a collection of rows, or a filtering of a section of rows. If you say have I mean, this is sort of obvious, but if you're just like returning records again and again, you like columnar formats may be very quick for answering some kinds of queries, but they're quite slow at returning rows. That's obvious, right? But it sounds dumb to say it, but that like either you store things as rows or you store them as columns is sort of one of these like big choices in databases, and it impacts things like write throughput and update performance. If the data isn't, if you're updating a whole row and they're in columns, you have to jump around a lot to get the update to work. So that is like one of these like fundamental decisions that you make.
That dichotomy of the row versus column oriented record storage is the fundamental divide that has introduced the practice of extract transform load or extract load transform, whichever sequence you want to do it in, because of the fact that if you have row oriented data, it's easy to insert an update, but it's slower to do aggregates. And if you're trying to do aggregates across your transactional database, it's going to negatively impact the application. So you move all the data to a different system to do all the analytics, which increases a lot of cost and complexity. You're duplicating the data, so you have to duplicate the storage cost. And so that's definitely one of the fundamental aspects of how do you think about the system, where are you primarily doing analytics or are you primarily doing single record events or updates, or what do you need to be able to retrieve?
Yeah. I think that's like I kind of think of this like the ETL problem is, yeah, I kind of feel like ETL is kind of this like problem of our own creation. There is this to sort of that thing that you I mean, this is like this is a sort of interesting thing, but there is this sort of there is this like historical myth that you can like have one database and you'll just like it will be huge and all of your code will access the same database, and and this is like a sort of, this is the business model of like general purpose database vendors, is that you're just gonna make one giant machine or a couple of giant machines, and it's gonna run DB2 or Oracle or one of these like behemoths, and it's gonna solve all of your problems with data, and this is like basically always been a myth for literally this thing that you just said, where if you run analytics queries against a transactional workload, then the workloads conflict with each other and they make each other slow, right? And the mechanism for this is like quite simple. You have more data than RAM. The data isn't in, the working set for your instance at any given time isn't in memory. But if you're really smart or clever, you can keep the working set for a given workload in memory, and you sort of optimize the workload and the application so that for the most part you're not going to disk as much as you can, and transactional systems use like indexes for this, right? And indexes are kind of like real-time ETLs of your system, in a lot of ways. There are things like materialized views, which are, again, the same kind of thing. And they like put the data in a different form and keep it up to date sort of sequentially, or like strictly like in a consistent sort of way. But those also sort of solve this, like how, like ways that we can kind of keep the data sort of positioned in a way that makes the queries that you're going to run stay in memory, not have to sort of bounce to random IO on disks a lot, and then you're sort of good. But if you have if you have too much of this going on, then the workloads thrash a limited set of memory, and then you're into this like, okay, we have to ETL and copy it over. You can also you can also imagine having like using read replicas to satisfy some of those workloads. You can imagine having, like having ways of persisting data that don't involve updates very much, right? There are these like event driven systems, and so you will like materialize out the row data, on some interval, and maybe that's like enough. Like you don't like having this, like having the objects be sort of strictly read from memory and like material like in memory as like a row and record is like maybe not always the thing that we need. And so there is like, you can write applications that do both, or you can have some of the, like you can use uh, materializations or other sort of tools within a system along with replication and all of this to get kind of to get the sort of query performance that you need for a given workload, right? Because some things, like you're always doing both, right? There's not a no, like, this is the application where we save numbers but we never average them, right? Like, no, like, okay, what are you doing? Like, that's not a thing. Stop it, right? There are, and you say there is this other thing of this like assumption that like ETLing is like all like has this like flaw of like your data's stale and you're saving another copy. But if you're doing like, if you're on some kind of event driven like message passing, like persistent, like using persistence via like with messages and records and events, then, and not like objects that you're updating in place, then which like that's a thing we do, like that's sort of like a pretty good way of doing things in a lot of cases. Then the thing that you're ETLing is archives, which you need to do anyway. And so like, and it's not even an interesting ETL at that point, right? You're just like streaming data out to a file, right? Like it's, and all of this to say, like, there are a lot of tools, there are a lot of these like patterns that we use, and I think that we tend to sort of default to using databases with in these like very sort of specific ways with like all of these like very, like I'm like kind of like picking apart all of your assumptions and all of your like all of these things that you're saying, but you're also sort of saying exactly like the thing that is sort of like the common way that we think and talk about these like solving these data persistence problems. Like, of course we use ETL or ELT or TL, I don't know, whatever. It doesn't like that this is, like processing your data and writing it, like it's called a query. Like, it's somewhat like ETL should like be just like, I've always sort of, like every so often I like stumble across an ETL tool. I'm like, you're just running a query in a cron job. Like, I get it. I like it. I like cron jobs a lot, but I think that we often, and we often sort of fall into like leading, and this is a like common engineers do this a lot, but you sort of start with the tools and work backwards to the business problem. And I think the like actually there it take like you need the sort of grumpy like architect or principal engineer type to sort of say like, okay, like let's back up and like go in the other direction and sort of say like ask why a few more times, like why are we doing this, and what is the thing that we're trying to accomplish, not like do we need to archive, do we need to get this one query really fast, or this other query, or we need write throughput, or whatever the issue is. So yeah, I think it's these are like really important questions, and it impacts like how we what tool, like if you get to the same place, like you still build a thing that works at the end of the day, but the sort of assumptions that you need a thing of a certain shape is leads us into some weird contortions, I think, actually.
That's definitely true. And I think another interesting angle to it is starting from that business case of I need to solve this problem. So, given the requirements, constraints of the problem space, I will then choose this, and this solution. Is that businesses and the contexts in which they're operating are constantly evolving. So, what is the right solution for a business at a certain point in time will not necessarily be the right solution for all time. And so, you get into those situations of iterative development, iterative architecture, evolution. And in a lot of cases, the database engine that you selected because you thought that it was going to solve all the problems that you had, and maybe it did for a time, then becomes a liability because the assumptions of the business are no longer true. So you need to be able to evolve to accommodate the new realities of what you're trying to solve for. And I'm wondering, what are some of the useful ways for teams to think about one, future proofing, recognizing that that is never the reality. You can never actually future proof, but planning for evolution of the architecture, and some of the ways that teams, when they do hit that point of realization that the engine that they have selected is no longer viable and is now a liability, how can they then make that transition to a new system as painless as possible?
Yeah, I mean, I think you sort of you got it in the like you can't future proof anything point. So now I have to think of something cleverer to say. Yeah, so I think that what you, I mean, in some ways, like don't try is sort of the answer is like, I obliquely referenced the XY problem of sort of jumping to a solution too soon. And I think the sort of the thing that you can do to sort of be the one who says time out folks, let's ask a few more questions, is to think that like, okay, I'm an engineer, i should I should always ask one more question, and not, or like I should always sort of state my assumptions. And often like that is the tool that you use to future proof what you're doing. I think the so that's a not, that's like too sort of hand wavy, because people will like, like engineers will almost always think that they're doing that and not quite do it. So like asking more questions, and like starting, like I assume starting sort of like every ticket with every Jira issue, every document that you write, every meeting with like, these are the things that I'm assuming, and then you sort of do design work and architecture thinking like based on that, requirements gathering based on those assumptions. The sort of not the sort of the second so that's like a whole kind of, we could spend, there's like a whole podcast series that we could have on that question. There's the sort of on the other side of it is this like realization that engineers have this tendency and desire to over engineer things, and to know that sort of this like planning for future scaling is always this like over engineering premature optimization kind of path, and to sort of in some ways just like spend less time thinking about it, because you're always going to have to do it again in the future, and you should wait for it to be a problem before you start optimizing it, or fixing that kind of thing. And that's like, okay, that's like really easy to say, but I think like having an architecture that makes sense for the team that you have, that like keeps like the assumptions like well declared, uses standard tools that do scale in some way. So right, like if you there's this like example, right? If you're like writing all of your data manipulation using pandas or polars, you have your queries written in Python. And if you then need to take your 4 GB data set, or your 32 GB data set, or what, or small n terabytes of data that have been running okay with pandas, and then suddenly like multiply it by 100, you have to redo it. Like it's just like, that's not, there's no way around that. You have to redo it. Fine, that's fine. If it were SQL, you may have to redo it too, but there's a chance that like the SQL will like translate better across scales, because SQL is declarative and it sort of says, this is the thing I want. You, Mr. Database, Mrs. Database, go forth and give it to me, and I don't care what you do on the inside. And you can sort of load the data into whatever tool you need to and see what happens in terms of performance. And so that sort of using tools in that way, like maybe is like the right answer, which isn't to say that like you shouldn't use pandas, because like a lot of times you're never going to do that, and there are, and sometimes the redoing it is less less intense in one way or another, or you have to like do some kind of early, there's a group by very early in your execution, and there's no way to have that query execute in parallel anyway, and so your scaling options are limited, right? So it's like very kind of use case specific about like which tools you use to kind of to handle that, which is why like all the things we said before about knowing what kinds of queries you're going to be doing, and how that relates to where the data is absolutely crucial. And then you sort of hit this scaling wall, or you watch the graph kind of get close, and then you sort of say, okay, now we have to like we deferred doing this earlier, but now we have this SQLite database, which is 2 terabytes, and we really need to like have it not be like on the application server, because it makes deploys take too long. Fine, right? Like I like a year ago, I had coffee with a former coworker who described the architecture of a component of the system they were working on now, and was like, oh yeah, it's like an EC2 instance with a really big SQLite database, and like it's fine. And I was like, but really, and if you think about it, like sometimes having the app and the database in the same place, like there was always going to be one thing anyway, and there are backups no matter what it is, and so you end up with these situations where like, yeah, actually, like people probably should use SQLite for way more than they're currently doing with it, and that there are ways to like architect that in a really sort of sane way. And then, and then there are sort of, you can kind of take that in lots of different directions, and having having ways of testing it locally, like the oh, this is just a SQLite database or whatever, is actually like gets you like really far, in a distressingly really far way. But if the like thing, if but like, and then maybe that's fine, and like you can later move it to Postgres or MySQL or whatever you want, and that like that gets you a lot. And and some of this is like, what tools are you comfortable with, and sometimes, and there are definitely database tools, right, like that do scale up pretty well along any number of dimensions, though it is also true. So like the databases that scale, like there are these like class of databases which have sharding built into the database. Cockroach, MongoDB. I mean, like, obviously, like, I know things about the MongoDB world pretty well, but there are Couchbase does this. There are like Cassandra's and other sort of native like sharding inside of the database tools, and they're really like, that's like next level stuff. It's also absolutely true that in practice, if you're gonna use sharding, eventually you sort of have to like know that you're potentially going to be at that scale, and like spend an hour making sure that you haven't sort of tied yourself to some kind of railroad track eventually, right? Like, there is this like, you kind of need to like plan how your data is like laid out in order to make that work. So it is the answer, the answer is sort of like, don't over engineer anything, upgrade, scale when you need to, use use the abstractions to your advantage, and also sort of gut check, like, it's not possible for this data set to get larger than 2 terabytes. Okay. Like, or this is a data set where we're like modifying things all of the time, but it's small. That leads to a different set of challenges. This is an append only data set. Great. There are different like, you if you start at a certain place, you like get to an end more or less quickly. And I think scaling is a thing that application developers who like, once you know things about how databases work, application developers are really the people in the best position to sort of, in coordination with the product managers that one hopes they have, or to sort of make these kinds of decisions, when building apps. But it's really sort of a thing that like works its way all the way up and down the stack.
Another interesting outgrowth of the complexity of selection of a database engine can have is that the engineers who are building on top of that engine become skeptical of the longevity of that system. And so they will refrain from actually taking full advantage of the capabilities of the database and instead move more of that functionality and logic into the application layer, so the application becomes more complex and heavier weight and harder to maintain, and the database becomes effectively just dumb storage. And so I think that that is definitely a risk that exists as well. And I'm wondering how you have seen teams try to manage that balance, or some of the ways that you think about how and when to actually invest in the capabilities of the database engine to improve or enhance some functionality or manage some of the actual application logic versus just being this dumb storage system.
Yeah, I mean, the things, like, I think this is like a class of like over engineering. Like, oh, we're going to put an abstraction layer in front of X thing because we might change it later. You're never going to do it, right? Like, sorry, like that's not a thing. Like, no. So there are a couple of like fallacies, I think, in the way that people think about databases and data selections. The first is that there's ever a day when anyone in the world ever wakes up and is like, you know what, today I need to decide if we're going to use MongoDB or Postgres, or we're going to use MySQL or Postgres, right? That decision has always already been made by someone else, right? Unless you are like literally like starting out, like we just don't make that decision at a low level. And the second thing is we don't change it. There are people who will there are systems where you do need to migrate from one to another for some reason, but that's incredibly rare. And you should, and sort of at the point when you need to do that, you have users and money. And so it doesn't, so you can afford to do it, right? If you don't have users and money, it doesn't matter, because your data, whatever it is, it all fits in RAM, and like you're not making money anyway. So who's going to pay you to like change databases? Like that's not what we're doing, unless it's for fun, in which case, go wild. But we don't have these kinds of like migrations happen very often. So these abstractions, like, you should have good tooling around your database that like lets you do it, but that lets you sort of like handle, like, have some abstraction between the database and your code, right? You shouldn't be like, I don't know, like writing your own database driver inside in your models package or whatever. But you don't need to sort of build your own abstraction on top of your database and do this thing where you put the all of your business logic in your app that could easily be pushed into the database, and would be faster and cheaper if you did it that way. Again, like, pushing things into the database is like writing SQL, and if you take a SQL statement and you're like, okay, now we have to take this SQLite and make it run on Postgres. One, that way should be pretty easy, and two, like, it's if what you have to do is go through and find a bunch of functions that don't exist, or and write them a different way, like that's a much less onerous kind of thing. Even the real sort of the thing that I think like you sort of have the question you posed was like, do you like take advantage of the database? I think the risk that people like, in some ways, like, it's not just like taking advantage of the database is like a relatively safe thing because people don't change. The thing that, like, I think is risky and people are less afraid of doing for the wrong reasons are systems that have user defined functions, which means that you've sort of pushed some custom logic into the database, which has to sort of run, and it's difficult to version it correctly, right? That's kind of terrifying and hard to migrate. There's also and various things like triggers and stored procedures and all that, like, have the same property. There's also, if you're using an extension, you get so for systems like Postgres, where you just like hot load code into the database, it becomes very version dependent, and using that functionality is like actually sort of that there is some, like, I get that gives me the willies. But I think that mostly like teams, I think mostly teams should just not be as worried about it, and think of these like adding extra indirection between the database and the application is really as really sort of a premature optimization. It's also true, having said all of that, it's also true that sometimes you do actually want to write application code. And this was like one of the things that like the early NoSQL, or like early mid NoSQL era really kind of like leaned into, is that you just, sometimes the clearest way to express something was, in fact, like writing a for loop. And you can't do it like all of the time, and it's not a universal rule, but sometimes that's what you want. like you just want a for loop, and having some application code, like there are times when you when it's fine, but I mean, this is like we're sort of all of my answers to this question are like, classic engineer. It depends, and also like have a really good understanding of the problems that you're trying to solve and the size of data at any given point in a pipeline, and and also sort of like try and avoid spending your time solving problems of your own creation, right? Like there are a lot of, like I think that like teams aren't going to do this for lots of reasons, but like in a lot of cases, ETLing is a sort of problem that we've created because we haven't sort of extended engines in the right ways, or we haven't provided like interoperability in one way or another. And like this is a lot of what GlarDB is working on, is this like, how do we provide the same interface but also not acknowledge the like reality of our database, this monolith of give all your money to IBM, get DB2, put all your data in there, go to sleep happy, is just not true. And there, or any it's very rare that you find an organization that has only one database or only one database type. And I think being pragmatic with that is really really sort of crucial, um, or a really crucial way of like avoiding falling into some of these traps.
I think that's probably a pretty good place to start to close out the conversation. So, is there anything that you think is useful as a closing argument, or anything that you want to say to wrap up that we didn't already touch on?
I think we certainly got through most of it, and there are definitely like a lot of like side quests in this conversation, which I think bear a little bit more attention at some point. I mean, I think the parting shot, parting wisdom is really like ask more questions and ask more questions, acknowledge your assumptions, avoid premature optimization, like be aware, and be aware sort of pragmatically of like what's going on, what's possible, where we're almost always data. We spent a lot of time talking about applications, but there's like on top of there's like core application developers, and then people working with data generated by applications on top of it, and which are themselves applications of a different sort. But that all of these projects really, there's like this like pragmatic, like this is, we don't have control of it. Almost every line of code, like people very rarely just like open a text editor and say, today I'm going to write a data driven application, right? This like another one of these like things that doesn't happen. Not, don't wake up today and decide which database to use. Don't wake up today with a blank application and no data, right? We're building on top of things. And so making it possible, and acknowledging that we're going to be pragmatic. We have to be pragmatic. This is like we're building applications and tools and software to solve hopefully as much as possible other people's problems, and I think like make it so that we can make decisions about businesses, about the world, about our organizations, about whatever the thing is, based on data and not vibes. And if we screw up with, like if a query is too slow, people are just going to make decisions based on vibes, right? People will always fall back to the like vibes driven decision making. And people do okay with their vibes, but we have all of these tools, we have all of this data, like being being sort of able to and flexible with building out infrastructure and tools around it is the thing that lets us make better decisions, more clear decisions about whatever it is that we're doing. And I think that's like a really that's the thing that's like important to keep in mind, and is, I know it has been true for a really long time. At the scales of 10 years ago are not the scales of today, and aren't going to be the scales of 10 or 20 years from now. And I think that's all of that's okay. And our jobs are to sort of make sure that we don't get we don't look back in 10 years and say, oh, we just sort of like did that all on vibes, and I think that's sort of the important part.
And I think too, making sure that you actually understand what the database that you're selecting is capable of and is optimized for before you decide to invest in it.
Yeah, absolutely. Like, know your tools. Like I as a programmer, I like have a collection of absolutely absurd facts in my brain about like what various runtimes do. Like like Python programmers sort of like have an intuitive sense of where the GIL is, like there are all sorts of cases where just like knowing your tools is really good and really like gives you a lot of power. And databases are kind of the same. Like it's a runtime. They all mostly use the same programming language, but it's all one of those. And so knowing how all of that works makes you a better consumer. And I think that's useful.
Absolutely. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
This is going to sound like it's out of left field, but I think easy to use testing tools are really is the thing that just like always feels like it's missing. You sort of write all of your application code. You can unit test a lot of stuff if you're like functional enough, but then you start talking to a database and you're like, well, okay, here we go. I hope I got that right. And there's nothing. There's like as great as everything is, there's just like absolutely nothing that exists where you're like, oh yeah, I want to run something that feels like a unit test with, I want to make some fake data, and it's just like doesn't exist, and there's no way to do it. And so, that's where all the bugs are all the time. Like, you spend, if you have an app that someone's using, and every outage, every user complaint is always something that isn't covered by testing. And we have these like great tools in other areas of our code for doing testing, and like there's some paradigm or syntax or something that just like doesn't exist today. And I think like that's it.
All right. Well, thank you very much for taking the time today to join me and share your thoughts on this overall space of selection and optimization around the database engine and how you're applying it to the problems you're trying to solve. It is a perennial problem and definitely subject to the overarching "it depends" answer. So I appreciate you taking the time to explore that with me, and I hope you enjoy the rest of your day.
Yeah, you too. Thank you so much.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.